Hello students, today my topic for the physics class is refraction of light. Okay, so for refraction first we must know it is unlike a reflection. That is, in case of reflection we have seen how light gets reflected back to the same medium from where it has come. But in case of refraction, it enters to other medium. Okay, so how do we define refraction of light? A ray of light, and when it enters from one medium to another, the direction of propagation of the obliquely incident ray that enters other medium changes. Here you see it has come here and then it has changes the direction. The original direction was this. This was the original direction, but it has changed in direction, that it has come towards the normal. Now why, that we will know afterwards. So at the interface of the two medium, this is the interface of the two medium, and the phenomenon is called reflection of light. There are two laws of refraction, the incident ray, refracted ray, and normal to the interface at the point of incident all lie in the same plane. And the second law is the Snell's law of refraction, when we have sign of the angle of incident. This is the angle of incident between normal and incident ray. This is the angle of refraction between normal and refracted ray. So the sign of the angle of incidence by sign of the angle of refraction gets a constant ratio, and this is called refractive index, and this is the Snell's law. Since it passes from medium 1 to medium 2, so refractive index will be the medium of refractive index of the second medium with respect to the first medium. So I have written mu2 with respect to 1. Now this mu depends upon wavelength, but it is independent of angle of incidence. If you have to note some important things, that if the refractive index is greater than 1, that means angle of incidence should be greater than angle of refraction, then in that case the ray bends towards the normal, and so the second medium is denser than first medium. And if it is less than 1, then I is less than R. That means refracted ray will bend away from the normal, and so the second medium will be rarer and the first medium will be denser. Now what is optical density? The ratio of the speed of light in two media is called the optical density. That is, for example, if you take the speed of light in turpentine and water, they are two different media. If you take the ratio, then it will be called the optical density. So our next point is refractive index in terms of velocity of light. It will, if light passes from first medium to second medium, then it will be velocity in the first medium by velocity in the second medium. Now what is absolute refractive index? If the first medium from where light is traveling is vacuum, then it is called absolute refractive index, that is C by V. And if it in terms of wavelength, we define refractive index as the wavelength of the first medium to the wavelength of the first medium, second medium, because you know V is equal to n lambda, so n being the frequency of the light. Now what is lateral shift? The next point is lateral shift. So when a ray of light is incident on the interface separating two media, the ray get refracted here. Now the original direction of the ray was this, but after refraction, when it has changed the path, that is the velocity of the light has changed, since they are two different media, then the perpendicular drop measures the distance between the two, that is the original what is called the original direction of the ray and the refracted ray, then that is called the lateral shift. Okay, now if we have a compound slab, that is A, B, C, again this is A, this is the air medium, so that means there are 1, 2, 3 medium. Okay, so in such a case, what will be the refract, how we will write the refractive index. Now before that, let us see what is principle of reversibility. Now if you have two medium and ray of light is incident on an interface, and if this medium, here you place a mirror, then the refracted ray after falling into the mirror is sent back to the same medium, is sent back in the same path from how it has come. That is called the principle of reversibility. Now according to principle of reversibility, if we define refractive index as first medium with respect to 2, the second medium as mu 2 with respect to 1 sin I by sin R, because angle of incidence is I, refraction is R. And when it goes back from this medium to that medium, that is 2 to 1, it becomes 1 with respect to 2, and angle of incidence become R now, and angle of refraction becomes I. So by multiplying equation 1 with 2, we get it is equal to 1, because this gets cancelled. That is, the ratio is, the multiplied factor is 1. Now, similarly, when we have 3 medium like this, A to B, refracting is B with respect to A. Then B to C, C with respect to B. Again C to A with respect to C. That should also be equal to 1 if you follow this. So this becomes equal to 1. Now, if you keep B with respect to A into refractive index of C with respect to B, this becomes the reciprocal. But we know that if 1 by the refractive index with respect to A, medium A with respect to C is equal to refractive index of C with respect to A. So, when I multiply refractive index of B with respect to A into C with respect to B, we can, this is this into this, and when you replace this by this, it becomes equal to this. So you can just see how it is. Refractive index of B with respect to A into refractive index of C with respect to B. It is just like in logarithm how we change base, like that. So A with respect to C. This is how we can relate refractive index of different media like this. That is called refraction through a compound step. So this is all I have for you today. We'll continue with the next class.